Hello, today I'll be talking to you about how to set up a Kinetics assay on a Core T200. First, we will open the software. So it will be this one right here, the Core T200 control software. Double click on it. So this will open the window that would display everything that is currently happening right now. If you actually see in the bottom left, it says not connected right here. So right now that system is connecting. Once it's connected, you can actually see it says online computer 1 right here. Okay, so once this is open, the easiest way to set up a Kinetics assay is to go to File, and then you will go to New Wizard Template, and it will give you all the different options that you can do. You can prepare a chip, you can do assay development, but what we want to set up is Kinetics assay. So you will click on Kinetics assay. This will open currently all the different folders that have like existing folders or existing files. So you will click on New. Now this will open this window. This is actually the setup of the assay. So first you will choose, depending on what kind of chip you have, depending if you have a CM5 chip, a Protein A chip, you will change this right here in this drop down option. So for example, we would click on Protein A. Now we will select which flow cells to use, 2-1, 4-3. Remember, 2 is where you flow your sample, 1 is your reference sample. In addition, depending on what kind of assay you're doing, if you're doing a direct kinetics assay or if you're doing a capture kinetics assay, you have that option here. So for example, if you wanted to capture some antibody, you would click on this one, and then you have a ligand capture. Now if it was direct kinetics, you will not choose this one because your antibody of interest will be already immobilized on the chip. Now in addition to that, you have regeneration steps. You will click 1 or 2 depending on which one do you want. In this example, we will click on ligand capture because we're theoretically capturing an anti-human antibody, and then you will click on next. Now this is the running condition. So for the running condition, it is always HBS. So we'll type it in. Contact time varies. That usually is 30 seconds. If you wanted to, for example, condition your chip in a way that, for example, if you wanted to make sure that there's nothing binding there, you could also use here glycine for this step instead of HBS. But normally I usually use HBS and it works fine. The startup is HBS, and the number of cycles is usually 3. Solvent correction is actually a separate solution. Normally I don't use it. This sometimes is suggested for small molecules. So now we go to next. Ligand capture. In here we'll put, for example, an antibody that we are trying to test. So I will call this IL-10 antibody, and this is an human antibody. Now the contact time will be determined in a different video. Normally you want to have the contact time that is equivalent to 100 RUs. So let's say that 30 seconds is equal to 100 RU of capture antibody at a flow rate of 10 microliters per minute. Like I said, this has to be set up in a different assay. You need to find out how many seconds you need for you to immobilize 100 RU of antibody. The sample contact time, normally it is 120 and 600 of dissociation. Sometimes you can add an extra step of HBS to make sure that the injection does not carry over any other antibody or analyte through. Regeneration step. This is commonly glycine 2.0, or 3 molar magnesium chloride. Contact time is 30. Normally I want to do a high flow rate, so I would normally do 50. This is my preference. You can keep 30. Then you click on next. Alright, so here you have the different concentrations of the samples that you're going to be trying to find the kinetics data for. For example, so this is the concentration of the analyte. We are going to say, as an example, soluble IL-10 protein. In here, let's say we know the molecular weight of the protein is 25,000 Daltons, or 25 kDa. Now normally I want the nanomolar concentration to start at 100, and you do 1 to 2 dilutions. Once you put in the nanomolar concentration, the system automatically gives you the concentration in micrograms per mil to do for you to be able to do the dilutions. And from there you can do as many dilutions as you want. So what I'm going to do is I'm going to copy this, paste, 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 and paste. And then I'm going to do half, 50, 25, 12.5, 6.25, and then we have to copy 25. You want to have a double injection that copies the, so you want to have a double one to make sure that the 25 matches the 25 in a different cycle. And we also want to have a 0 injection to make sure that's your baseline. Once you do that, you click on, so like I said, you go from 100 to 0. 100 to 0, meaning you do different dilutions, and you do a repeat to make sure that they match. And on the right, it tells you the micrograms per mil concentrations that you would need in order for the machine to be able to have 100 nanomolar concentration or corresponding concentration. Once that is set up, you click on next. Do you always want to have prime before run? And then you are able to see this window where this is where you're gonna load your sample. So each one of those each rack is different, so you can change the rack. So you can change to the sample and reagent rack, for example, and you can actually put anywhere you want the sample that is going to be injecting. So for example, this one is going to be here, this one's going to be here, and then in addition to that, you know the volume needed right here, so it tells you that you need 128 microliters, and this corresponds to 100 nanomolars, and this is for the soluble IL-10 protein that will be flowing through. And then the antibody of interest that we're capturing is right here, is the IL-10, and you need 230 microliters. If you wanted to, let's say, pull together the ones that are the same concentration, for example this one and this one, which are both 25, the way to do that is you click on menu, and then we go to automatic positioning, and then you say automatic pooling. Instead of auto, you click on yes, and then you click on apply. So now what happens is that the 25 got pulled together. Now you need 226 microliter, which is double the one of 118. Sometimes this is not recommended because of evaporation, and evaporation plays a factor, but if it's a quick run, I don't think it will play a huge factor in your kinetics assay. Once you do that, you click on next. Alright, so here is the last step where you will be running the assay. You can hit start. Once you hit start, you save the template as a particular template that you are looking for, or you want it to save it under as. But if you don't want to save it, that is also fine, because you can also set it up every time you need to do it. So I'm going to click on don't save, and then it tells you where to save the results, and you can go to different folders. And this concludes the way to set up a kinetics assay.